We'll get started here. Good afternoon, everyone, and welcome to the first session of ETE 2021. I'm Matt Swartley with Chariot Solutions, and I'm here to introduce to you to Bergh, Johnsson, and Daniel Deogun. They come to us from Megapoint in Stockholm, Sweden, the market's leading consultancy in cybersecurity and secure digital transformation. Dan and Daniel are also co-authors of the book Secure by Design, and they're going to take us past the fundamentals and provide us with the insights, pitfalls, and other lessons learned from applying the concepts from the book in the real world. So please welcome Bergh, Johnsson, and Daniel Deogun.
All right. Thank you so much.
Thanks so much. Yeah, calling in from Northern Europe, Sweden, Uppsala to point today. And hey, it's an honor to be part of such an stellar lineup as the Phil AG has got this year. It's really humbling.
Right. Let's see if we can make this work. Dan, let's start by giving the boring stuff in this talk.
Yeah,
right?
Of course. Yeah. So, secure domain philosopher. Well, that's me. I'm a programmer by profession and education. Been working a few years, a few decades. Always had an interest in security, but come from the crafting part of software. Do also a little bit of the organizational stuff. So coding, architecture, but also some organization, agile work sets, etc. and stuff like that. And I've also got a faiblesse for philosophy, so I might end up out on a parable at some point, and at which point I need someone to pull me down.
Right.
So Daniel, what's this code and quality defense? That sounds very down to earth.
Well, I guess I am. I tend to be very close to the metal. I'm a developer at heart. I tend to be coding architect in projects. I specialize in the crossing, I guess, between security and application development. So writing the book Secure by Design has been I would say pleasure, but I guess my wife would disagree. It's been a fun journey, yeah, let's skip this boring stuff now and move on, right?
Just to be sure, we started working with, we've been working with the ideas behind Secure by Design for like a lot of years. Yeah. And then we started writing in the book about 5 years ago. So that's when the ideas got crystallized, and the book came out 2 years ago, or 1.5. So what we want to share today is more looking back at those ideas that we have kind of like crystallized and Secure by Design, and see what happened to them in practice. Right. So this is just not about the basics.
So we will, of course, give you a brief introduction to Secure by Design, since it might not be known to everyone. But then we're going to focus on 3 particular aspects that have been very important in the field.
Well, one of them being the concept of domain primitives, which is a substantial part of what we've written in blog posts and in the book and presented at conferences, and of course what we've done in practice in our projects. So, but it didn't turn out that everything we said and wanted and thought about domain primitive actually landed exactly as we thought we conveyed the idea. So there have been some slight misconceptions, and we want to have a close look at that.
The same thing goes about validation and the importance of validation. That's another concept that we stressed a lot throughout the years, and there's been some subtle mistakes that's been made that sort of created some interesting new, how should I say, side effects.
So some parts or aspects of validation kind of get into the shadow of other things we've perhaps shown the light to focused on.
And the last part that we're going to talk about is the importance of externalizing secrets, and that's going to be a bit more complicated than the other ones. So please stay tuned.
So just to say, of course, Secure by Design covers a lot of different things, from coding to testing, to pipelining, to architecture, etc. And we wanted to show a little bit diverse part here. So domain primitives and validation is kind of like code-ish. Externalized secret is more architecture-ish. So we think we want to cover a little bit of the span that Secure by Design covers.
But since this is a very cool conference, there's a lot of cool sessions running in parallel, you might have to leave. So in case you do that, here's the summary.
So these are the takeaways. Yeah. So Secure by Design, in a nutshell, it's a mindset for creating secure software. And it's piggybacking on our drive to use good designs.
And the domain primitives part is actually interesting in the sense that misconceptions in how people create them yields anemic domain objects. And these domain objects actually could open new security vulnerabilities. And that's, of course, not good.
When we talked about validation, then it became a focus on input validation, so that the also important state validation came a little bit in the shadow, and that also led to other problems of also opening up security vulnerabilities in that field.
Right. And finally, the secrets, that will be, our focus there will be on secret rotation and how you do that efficiently. And I guess the major pitfall that we've seen that we have called config injection at startup.
So this summary, hopefully it makes a little bit of sense right now, but hopefully will make even more sense when we get to the end of this presentation. Right. So let's get into the meat.
Yes, let's start. Software bugs, Dan.
Secure by Design, what does that to do with software bugs?
Well, as you all know, I mean, the entire realm of bugs, I mean, they're different kinds. One could be, incorrect color of a button. Another might be, leaking personal data or sensitive information.
Equifax.
Right. Or it could be, the fact that you are, losing money somehow, right?
Or make your engine have a higher consumption of fuel, or make that video game flicker, or whatever it is. So undesirable behavior of the software. So, but security bugs, I mean, is security just bugs?
Well, the interesting part is that depending how you view a particular bug or an abnormal behavior is that you can categorize it either as, a security flaw or just a bug.
So in our conception, we think of bug security problems that there's no essential distinction between security bugs and normal bugs. It's misbehaving code that should have a behavior or should have a limited behavior, but has another behavior or an extended behavior that's undesirable. And if that behavior causes effects on confidentiality, integrity, availability, or traceability, then it's a security concern. So then it's a security bug. But it's not really anything different than other bugs. So how do we avoid bugs?
Well, there is a very simple strategy. I mean, if we use a certain design pattern, that pattern itself is going to, address a certain set of problems.
And with design pattern, we don't mean anything fancy here. It's, for example, object orientation, encapsulate your data in behavior inside an object. Right. Do not leak the implementation to the rest of the program. That's a design pattern. Risk of substitution principle is another pattern, or injection of inversion of control, or et cetera, et cetera. So by using one design principle, you reduce a certain class of bugs. For example, here, a little bit piece here, some of them are security bugs, some of them are not security bugs. But of course, we haven't got only one design in our hands as software developers. We've got a lot of them. We've learned them at the university. We've learned them while reading blog posts, etc. So we've got this whole realm of software designs that we use, because we do, don't we, when writing code? Because no one in this room will ever write code that doesn't use all those smart and really intelligent designs that we all know that we should use. Sometimes we cut corners and do not use the designs. We know that we should have encapsulated this into an object, but we didn't because of stress, because of project pressure, because of laziness, because of tired, because of didn't know how to handle that connection, because of a lot of reasons.
But Dan, these are design patterns. What about secure by design? What is that then?
Yeah, what we did was that we realized that, well, some of these design patterns, designs address bugs, of which some are security. So we started collecting those designs. So here we got those marked in green. 4 of them, they all covered to some extent some security bug. So that means that if you apply this design, even if you're not heeding for security, you get some security for free.
So you're saying then that a particular pattern that I guess creates great software, but gives security improvements as a implicit, how should I say, benefit, then that would be a typical pattern used in secure by design.
And that's why it's easy to use, because we all know that thinking about the domain model, we think about the scalability of the solution, we think about the designs, we are having the feature that we want to do, and also thinking about security. It's a lot of cognitive load.
Okay.
And if we focus on designs that also give security benefit, then it feels natural for us as developers to say, yeah, I want to craft good designs. And then we got some security for free, basically.
Okay. So if you want to put this in some more fancy words, this is what we wrote about, that secure by design is a mindset and strategy for creating secure software by focusing on good design.
Yeah. Even though those designs were not originally conceived for security purposes, we still get the security, which is the good part.
As we said in the beginning here, that secure by design is a lot. It covers a lot in the book, and of course we can't cover it all in this session. But what we're going to focus on this time is the domain primitives part, since that's a very essential part of secure by design.
It's something that we've spoken about and presented on extensively.
Yeah, and then we're going to look at the secure state handling, and especially the state validation part. Mm-hmm. And we're going to dive also into one of the R's in the 3 R's of enterprise security.
So the 3 R's of enterprise security is the ability to be able to repave your instances, to repair your patching, and to rotate your secrets and tokens. So one of the cornerstones of that is the externalization of configuration, which is something we were spoken about, and where we want to share that we've seen some pitfalls and misunderstandings, and what we want to clarify what we think are the main benefits and how they should be done.
Good. So now we sort of gave everyone a brief introduction, a quick introduction into secure by design.
This was a 10-minute introduction to something that we worked on like for years.
Yeah.
Holy crap. Okay, so first topic. So
domain primitives.
Okay, so we're going to have a little bit of a retrospective. We're going to have a look at what we actually said and what we stressed.
I guess the misconception is something I'm going to bring out, what we have seen.
So we've seen people practicing it, sometimes in our own projects, sometimes in other projects, sometimes in other people's code, sometimes in our own code. And what we say that, oh, this didn't turn out as actually as we thought and wanted. So clarifying what we really intended.
And we're going to give you some insights and critique as well.
Yeah.
To sort of be fair. I guess this is a very different talk in that sense, that we're going to be pretty hard on ourselves, I think.
Yeah, this is a very Swedish talk.
Yes.
Swedish, Finnish style.
Yes. All right. So let's dive into this.
Okay. So what did we say when we talked about domain primitives? Well, when we introduced domain primitives, we said that this is a design which builds upon the value objects in domain-driven design, but also stresses these value objects are so precise in its definition that the mere existence of such an object will manifest its validity.
Wow, that's
a mouthful.
That's a very precise thing, but yet is so vague. I don't understand it.
So one of the things we really want to stress is it's domain primitives. So it should be stuff that is native to your domain. It's immediately understood in the domain. It's not big fluffy concepts like, can we take from the hospitality domain?
Oh, okay, maybe a room number.
Room number. Oh. So if I walk up to the front desk and say, this is my room number, they immediately understand what I'm talking about. If I'm walking over to a restaurant and say, this is my room number, can you put it on my room tab? They immediately understand it. You do not need to explain the concept of room number. It's native to the hospitality domain.
But what about the preciseness thing?
Yeah, so the preciseness is that we really want to say that in this domain, we limit the room numbers to be what is particular for this hotel or this chain, because room number can look in a lot of different ways. It could be ABC 1 to 3, it could be names, it could be, but at this particular chain, the room numbers are 2 letters and 3 digits. It's named HB 617. So you can't have a room number that doesn't adhere to those rules.
So basically what we're trying to say is that a object defined as a domain primitive, a room number in this case, can only exist in the code if it is considered valid in that particular context. So let's jump into another example.
Yeah. So Swedish Text ID.
Yes.
So Swedish Text ID is something, it's a text identifier. It's kind of similar to the social security number, and it's used to identify a person very often in Swedish or Nordic systems, and considered as a string.
Okay, a string, you're saying. But there are very particular
I guess you all have seen things represented as strings.
Yeah.
Yes.
But wait a minute, we have 10 digits. And in the example there below, I see 660525-3225. What does that mean?
So this is an example of how specifically a Swedish Text ID looks like.
Mm-hmm.
So if we want to pull this apart, then the first part there is actually the day of birth. 1966, 25th of May.
Okay.
And then we got a unique birth number for that person, which is 322.
Okay.
Which, by the way, also encodes the legal gender. So this is a even number, the last 2, meaning that the legal gender is female. And the second example, we got 239. We can deduce that's a male.
Okay, so by looking at the 9 here, I could say that, since that's an odd number, I know that this is going to be a male.
Yeah.
And this one is even as a female then, okay.
And the last number, the 5 and the 9, they are actually control digits.
5 and 1, right?
Sorry, 5 and 1. Yeah, are control digits to ensure that there's no mistake in typing.
What about the hyphen or dash? Yeah.
Oh, yeah, the hyphen's just there for decorative purposes.
Right.
However, should the person be older than 100 years old, so in the last example, if we'd been born in 1902, then the person would be 117 years old, not 17 years. Oh, sorry, 119 years. Then the dash would actually be changed to plus sign.
Oh, interesting. So what we can say is that a tax ID is very intricate. So the question comes then, how should we represent this? So if you look at some, typical code.
Yeah.
Yeah.
Well, a lot of time this is represented as strings, but because, well, it's digits and it's other signs, so it's not an integer, so it's a string.
All right.
But it has got its limitations. So
I guess if you look at this now from a security perspective, we end up in trouble.
Yeah, because on the inside, we have logic that are assuming that input is a text ID. And for us as developers, we get the guidance to pass in the correct parameter by argument, because the parameter name states it's a text ID. However,
the attacker, it looks at strings. And what can you fit in a string? Yes, anything,
well,
right?
Anything, an attack vector.
Mm-hmm. So that means that if you write this type of code, well, it's going to behave correctly as long as the input follows the assumption of being a tax ID. Whereas an attacker, of course, violates that and they inject something bad. Okay,
so what can we do about this?
Yes.
This assumption.
Right.
Instead, we take the type system. If we got a strongly typed language, this is easy. If we've got a weakly typed language, well, we're going to have a few more tricks around it. But basically, we can create a domain primitive text ID, which is built in a way so that it's satisfying the requirements of text ID. You can't create something, it's validated, it's immutable, it can't be changed to not adhere to the rules of text ID. And well, what's the security benefit?
Well, I mean, it's almost obvious, I think. But the fact is that by doing this tiny little trick, we sort of limit the attack vector to only be acceptable IDs. So it has to be a valid tax ID according to the rules that can be injected into this piece of code. And then the difference becomes that an attacker it's a lot harder for an attacker to put something in there.
Yeah. By the way, we got a quick question here from Dan Markley, who has asked if the switch for birthday separators between where the plus and minus is a solution of the Y2K problem. Well, kind of similar. It's rather the way that for having Swedes turn 100 years old was something that was really, really there were national use, so that didn't happen often. So the problem didn't turn up in practice in the paper era, but when life expectancy ended up being longer, it became more and more common. So then it became a practice among the government agents to mark that by adding an extra line on the dash, making it into plus sign. Now, there are modern extensions to the text ID that takes the century into account. So it's correct, it's the same kind of problem as the Y2K problem. It actually predates the Y2K problem a few decades, but you got the basic idea right.
Right. Okay, so what was I mean, this seems pretty obvious, right? You create this domain primitive, it limits your attack vector, it's validated, it's immutable, everything is fine, nice. How can this ever go wrong? Well,
it turns out we stressed the validation so hard that sometimes you find code like this. So this is a list sieve that looks through a list of text IDs and find those that are eligible to vote, which in Sweden is when you're 18 years old. So you got this for loop, which pulls out the sign, the year, day, month, and some computation for getting the date of birth, and then checks if the date of birth plus 18 years is before the election day, and then you add it to the result list.
This almost looked like, well, it's kind of messy, but is it really wrong?
I mean, does it work? It's work.
Well, there are two actually problems in this piece of code.
Okay,
one being there's actually a anemic behavior. This entire behavior of sort of saying, is this particular person with this tax ID eligible to vote? If you just look at the age, then that should reside inside of or be encapsulated in the tax ID primitive.
For those of you that have read Fowler's excellent work on refactoring, this is the feature envy smell. Yeah. It pulls out a lot of data and does the computation on the outside.
And the second problem is, of course, that by pulling this outside of the object, then suddenly you get different versions of the code. And this particular version actually contains a bug. And that you can see on this particular line here.
what happens if if the election day is actually on your birthday?
On your 18th birthday, right?
In that case, you will not be selected to be eligible to vote. Whereas according to legislation, you are.
So not only is it messy and it's prone to errors, it's actually something that we consider wrong.
And the reason for this is that what we've observed is that this kind of code, which resides outside the object, will be a once-off code, and it will have some unit tests, but it will not contain extensive unit tests of the date calculation or the logic for selecting whether you are eligible to vote or not. It will have some rough testing that ensure that you get out an empty list if you pass in an empty list, if you get some selected, but it will not test all the edge cases. Yeah. And which is a pity, because the same code is probably repeated roughly in a lot of places.
So what we really intended, right? That was, of course, to build on the original ideas of object orientation, right?
Domain primitives is not another design pattern than object orientation. It's building upon the basic ideas of object orientation.
And one thing that we should have stressed even more is that a domain primitive is really a small, intelligent machine.
So it's an intelligent machine, and to use Alan Kay's metaphor, that the big idea is really about is messaging. It's certainly humbling to be on the same conference as he is, but when you pass something, you ask an object for something, and it tells you something. You're not reaching in and grabbing out the data. It's about encapsulation of the behavior, not just encapsulating the data field, encapsulate the entire behavior, hiding the state, hiding the complexity, hiding the interpretation, and just giving you the answers.
And if we carry on and see, this is how we intended the tax ID to be designed. Basically saying that there's an immutable object that validates the rules that we talked about before and implements an API that encapsulates this behavior.
So you don't have to remember that it's odd or even number that encodes male or female. You ask for the gender. You can check if it's eligible to vote at an election day. You can get the age, and you can actually look at the birth region, which actually is encoded there for people that are born before 1990.
And then the code suddenly becomes something like this, which is actually almost like cheating, right? And
this is not code. You just write. Daniel, this is not code. This is you just write what you want and you get it. Yeah. That's not coding. That's cheating.
It's become so simple that almost anyone can read it. You stream all across your tax IDs and you ask the tax ID, are you eligible to vote? Yeah, and you collect the ones that match. And of course, then you say, oh, wait a minute, where's the logic for doing the computation that we saw earlier? Well, of course, that's encapsulated inside of the domain primitive now.
And the big difference here is that as this is stated in one isolated place, it's also much easier to write that unit test that tests date of birth or tests the eligible to vote, including a few of the edge cases. And that means that those unit tests will suddenly be written. There will be a moment where there are two programmers sitting and decide, should we commit this? Should we merge it into master or not? And one of them will say, I think we should add a unit testing for 18th birthday. And then if the code is corrupt like this, the other programmer will say, yeah, that's not a big job. Let's just add the test. However, in the other example, they will go, oh, that's messy. Now we need to proceed.
And the interesting part here is that, of course, the tax ID becomes a validated building block that you can reuse in all those places where your tax ID should be used. And the same behavior is used everywhere.
Yeah, it suddenly grows up to be a valuable member of the society of which it forms a part.
Yeah. So why did this not happen then? Why did we end up in
these misconceptions? Yeah. I think we used security as a selling point, saying that, hey, if you use good design, you'll get security as well. And people go, yeah, that's nice, because getting security is kind of hard and underrepresented. So security is an interesting trait of domain primitives, and people got hooked on that. But
it's not the most important one.
Certainly not the only one, and not the most important one.
And I would say that, you know, our main problem when we tried to, you know, convey this message to everyone was that, you know, if we would said just use plain old object orientation, people would go like, oh, that's boring.
Yeah,
I don't want to listen to this. Yeah, only to do this, right? But now when we say, you know what, if you want to, you know, limit the risk of injection attacks, you should use this design pattern called domain primitives. Then it suddenly becomes interesting.
Yeah, but we still want to stress that domain primitives are not a security tool. It is a design which has got security benefits, although that it was not originally devised with security in mind. So I guess the takeaway for us is that we focus so much on security that we made people forget about the original sentiment of the design.
And they basically created a more, I don't know, strict type system with validated anemic objects.
Yeah. Which is not a bad thing.
Yeah.
It's not a bad thing to have a high-class type system, but it doesn't give you the original benefits that you think really should want as well. Yeah. So it's become like a little bit designed by secure instead of secure by design. So
yeah. All right,
okay.
Let's leave domain primitives and move on to some validation and states.
Pick up the domain primitives in the second book, Secure by Design.
Right, so now you know the drill. So let's jump into what we said.
We jumped off the springboard that we actually want to give credit to security researcher Dr. John Wilander, who compiled a list of the order of validation, which is a 5-step process. So,
what do you mean by origin? That's the first step here. What does origin mean?
Yeah, origin means that you check the data is from a legitimate sender. We got a IP access listing. We got some kind of JWT token or API key or something like that, ensuring that, well, if some random dude off the internet sent me a gigabyte of data, I'm not even going to look at it. It's like, not the legitimate sender, throw it away.
Okay, so that makes sense. And then we have size, right?
Yeah, same thing. Okay, legitimate sender, but still, hey, it should be a password, but it's a gigabyte of data. I'm not going to open this package.
Okay, all right, that makes sense. The third thing is kind of odd, lexical content. What does that mean?
Okay, it's reasonable size. Let's just check that it's got a reasonable content. Are the right characters, the kind of characters and encoding that I expect? Yeah, looks good. Otherwise, this is some crap they're sending me. I'm not going to look at that further.
Okay, syntax then. I mean, it wasn't that syntax you talked about? Or
not quite. Syntax, we mean like, okay, so this is a JSON structure. Let's start parsing it and see what it actually consists of.
Okay.
So, and that's why we want to protect that poor parser, because throwing a gigabyte of unstructured data on the parser will just dose you. So now we've got the confidence that, okay, let's take this gigabyte of JSON or whatever it is, or kilobytes of JSON, and actually parse it.
Then the last part, semantics.
Yeah.
I mean,
okay.
Yeah.
Thanks. This is some piece of data. It's well hooked. It comes from origin. It's got the size. It's got the lexical content. It's got the syntax. Now let's see if it makes sense to apply this data in this context. Then we need to probably hit the database to see if this order number exists and what state it is, etc., etc. So all the steps before protects the next step. And the step for the semantic step, we need to hit the database, get the data, and start processing it. So we want, before we do that, we ensure that this makes sense at this point of time.
Okay. So what's the misconception then? I mean, this was kind of clear to me, at least. I mean, there are 5 steps, 5 things to do, starting with the origin and then ended up with semantics, basically.
Yeah. It turned out that the word validation seems to be troublesome. So how was validation interpreted?
Well, from my experience, when I've talked to developers, many tend to associate validation with input argument validation.
Okay, so it becomes kind of like a border concern, saying that we pull things into our system, we should validate it.
And it's sort of like the origin part. Well, we leave that to some sort of infrastructure that could be, checking that the token is correct and so on, right?
So some kind of API manager or gateway or something.
And then they tend to focus on especially step 2 and 4, and sometimes step 3 as well.
Seems to me that this is actually something that could be done pretty easily in the constructor of a domain primitive.
Right, yeah. I mean, you would check the size. Let's say it was a string. Does it, is the length below something or exactly at something? You would say, oh, does it contain the correct characters? I mean, does it match A to Z, 0 to 9, and so on, right? And then, of course, you want to say, oh, I mean, is it structured correctly? It's something that we,
And sometimes input data is complex, so it's a nested structure of JSON something, and that will be parsed and turned into domain primitives that we can apply into your system.
Right.
So, but what about the last part?
Well, this is the tricky part. Semantics is something that a lot of developers tend to go, I don't know what that is. And of course, it makes sense. I'm passing it some data, so I'm good.
So I'm going to add this. I'm just getting that I'm going to add some book to a book order. So, well, I'll do that. Of course, if I'm asked to add a book to a book order, well, then it does make sense to actually do it. So does the data make sense? Duh.
Of course it does. Well, let's bring up an example. Okay, book order example.
Okay, so here we've got this typical split. We've done our homework. We've crafted domain primitive. It looks like that.
Oh, an ISBN. And an ISBN.
Goes all the length check.
Yeah.
Cars, regas is also checking the checksum. That's excellent.
Mm-hmm.
So on the right, you have got the book order.
Yes. And this entity seems to, let's say we check for not null, of course, and then we check in the inventory.
Okay, the book is available. Okay.
Adding a book to the order, I guess.
Yeah.
And
because if I'm asked to add the book to the order, of course, that's what I, as a book order, is going to do, because that's my raison d'être. My purpose of life is to add books to orders.
Okay, so how do you know if it was allowed or not?
Of course, it's allowed. Otherwise, the caller wouldn't ask me to.
Ah, okay. So what we really intended when we did this was to avoid that particular type of problem, right?
So did we actually validate that you are allowed to put this book into the order?
Not at all.
What if the order has been paid, but not yet shipped?
In that case,
are we then allowed to add a new book to the order?
No, not at all.
And the only guarantee for that not happening is that there is no code that tries to do that.
So it's an implicit, how should I say, check or assertion that it doesn't happen, right?
Yeah, it doesn't happen by not happening.
Yeah,
which is excellent.
And then we come.
But there's no safeguard.
We come to this part where we say, okay, so what did we really intend, right? Well, I guess the first part is right. I mean, how they interpret it, that origin that could be handled by the infrastructure, right?
And perhaps, just to be honest, the size could probably also be upheld by some infrastructure, at least to some extent.
Yeah, of course.
But the rest of it, it's validation.
Yes.
It's just levels of how much you risk by doing it, and therefore why you want to do it in that order.
So let's go and look at the example again. This is what we intended them to do when validating semantics as well. We
want it to be explicit. So in the left-hand side, we have got that we extended the code by having add book, not only safeguarding not null in data, but also validating that it keeps track actively and explicitly keep tracks of what state it is in, and ensures that this state is open, thus meaning that it can proceed with the code, which now, looking at checking inventory and adding book to order, knowing that add book is allowed. So we want this to actively be explicitly stated and tested.
So if you look at it on the right-hand side, you see some pseudo rest, I would say. You can basically post and add new books to your order as long as it is open, I guess. And as soon as you have shipped it, well, then you can't add books anymore, because then you get a 405 back, right?
So this does not only apply to like coding level, but this is kind of like architecture level. And the HTTP specification has got a 405 method not allowed for this purpose. So, and unfortunately, when we look around, we very often see REST style APIs, but very seldom see a REST state API, which documents that it will give a 405, which means that it doesn't contain any state controls at all, which is odd.
So then the big question then comes, why did we end up here? Right?
Yeah. So the self-critique here, or the insight, is that the validation, the word validation, is often interpreted as limited to input validation, which does make sense because a lot of things have been written this. The OWASP coding guide talks about validation, talks about input validation. And we have ourselves repeatedly stressed the importance of input validation.
I mean, we've given a lot of talks where we talk about this.
Where we have mentioned domain primitives, we've been talking about input validation. But state is often not explicitly modeled and represented in code.
And by that, we really mean that, in the add book example here, that the only guard or assurance that we wouldn't call add book in an inappropriate time is sort of in the process of the color flow, right? I mean, if you're in one particular place, you can add books, and then you move on to another place in your flow, and then you should never call add books anymore.
And to be honest, if we look at code bases we have been participating on ourselves, and code bases that we've come across, and code bases we have audited, there's a lot of them, there's always some kind of entity somewhere, but almost never we find guards of the kind of like is valid state. Very, very some. Please make a regex grep on your code base and see if you can find any is valid state in your code base. Please call us if you find anyone.
I mean, and then the irony of it all is that, of course, I mean, we wrote about 2 chapters about this.
I mean, the book is like, it's like 14 chapters, and we've wrote 2 full chapters, and they are not thin chapters either, on this in the book. But did we present any talks about it?
Well, not this explicitly, I would say. So that, maybe we need to do it.
Perhaps we should take a note of that.
Yeah. So that's the thing. So having this in mind when you validate your objects, then things will be better.
So by now we've talked about the domain primitives, which is very codes focused. We've talked about the site in data validation, state validation, which is code and architecture. And now we're going to move over third subject, externalized secrets, which is really architecture heavy. Mm-hmm. So we're talking about how secrets are represented in our components which we deploy.
Okay, so let's bring on what we talked about, right?
Okay, something we stressed was that secrets, they should not be bundled with the application.
Because the secrets, they are varying between environments. It could be, the access credentials to a database, or it could be, an API key to something. And those are tightly coupled with the particular environment in which the application runs.
So they are not properties of the application. The most extreme example would, of course, be to hard code those things in final strings inside the code base.
Right.
but more soft or realistic is that, well, it's in the config file which is shipped together with it or bundled with the application. And that is where we want to move away from by externalizing them and then providing the secrets to the application instead in the environment which it's running.
And this sort of makes the application, I would say, environment agnostic. It can be deployed in any environment as long as it gets the secret, it can run.
But we realized that we have been a little leaving room here for some ambiguous interpretations.
Right. So what's the misconception then?
Well, the typical misconception that we've seen is that this is interpreted that you do config injection at startup. So when you start up the system in an environment, you have some kind of config phase that injects the environment properties into the application at startup.
So in this particular example, we see here on the left, we have two instances. They could be microservices or whatever. They have the secret X.
So when they want to connect to the database, they have got the X, which is the password, and they can connect to it.
And then there's some change operation. We go X goes to Y, and we end up in this.
This is what we actually want to get to. We want to be able to change those. You know, the production database password that has not been changed for 10 years. We would like to be able to change that.
So one of the security aspects is, of course, that if you start to rotate your secrets in a frequent manner, then if some evil Knievel out there gets hold of a secret, it can't be used for very long.
So the problem here is that when you start rotating the password, changing the secret to Y, then the new instances that are started will have the new secret and will be able to connect to the database. However, the old instances have still got the old version embedded inside them and will not be able to connect to the database. So they will experience permanent errors, non-recoverable permanent errors.
And of course, in such an environment, what we would, I guess, need is that the database needs to support both X and Y. In that case, all of these instances would work, and then redeploying new instances of these would actually get secret Y, and then you can remove secret X.
Unfortunately, not all production databases can provide support for double passwords without some heavy tricks with the multiple connection strings and stuff like that. So we tend to get a little bit stuck here.
Right. But what we intended
when said that the secrets are provided to the application is that will be provided when needed, provided on demand.
And if you're in a cloud environment, and not necessarily, but having an external vault, or if you're in a poor man's land, you can of course use your very private database with these secrets. Then suddenly your services, if they fetch those secrets when needed, then of course we will only have an intermediary fault, and the services can recover and self-heal whenever they are outdated.
And of course, you might not be in a cloud environment where you haven't got this kind of vault service from out of off the shelf. But then you will have to write something on your own, take a database and say that this is my vault, provide it with some extra security, and then pull in the appropriate functionality around it.
Yeah. So the big question, of course, then is, why did we end up in an environment where you have this injection at startup sort of behavior?
Which is kind of like a dead end. It takes you a little bit en route towards this rotation of secret. But We think that what we're overstressed is that we're overstressed that you want to get away from config changes through rebuild and release. We do not longer want to have bake on build, but instead we've got bake on deploy.
And I think also that in some, how should I say, IT landscapes, the maturity level is quite low, which makes it, you know, the step from actually having those hard-coded or part of resource files or whatever they do, going to the final goal of allowing secret rotation it requires a lot of work. So what they do is they say, oh, you know what? We need to externalize our secrets and provide them to the application. Then we are on the path towards this goal.
And you take a path away from the bad spot, but you kind of like just take a half step, and then the other half step is actually going into a dead end.
And why we're saying this is a dead end is because let's say you have 200 services. And you take on this work of, you know, we externalize the secrets, but then you realize that, wait a minute, we should have fetched them, you know, when needed. Then you need to rewrite all those 200 services.
So, but we realized that we perhaps shouldn't be too harsh on ourselves, because this is a young field. It's not an old and mature field. This kind of ideas were thrown around more explicitly around 2016-17. The 12-Factor Manifesto did an excellent work on actually publishing these ideas, but even they are kind of like, they say that you should store config in the environment, not in the application, but the fetching mechanism are not clear. Of course, you can read it and say, this can be interpreted to be that you should fetch them on demand, but doesn't state so explicitly. Also, I mean, Justin Smith.
Yeah, that was I mean, his talk about the 3 R's of enterprise security, that came out there some around,
I think
that
it was
time, I think
2017.
Yeah.
Which, by the way, it's an excellent article. If you haven't seen a presentation or read an article by Justin Smith on the 3 R's of enterprise security, rotate, repave, and repair, please do. It's excellent inspiration.
Right. So the summary. Now this probably makes sense.
Oh, hopefully.
Yeah.
So secure by design, as in general, it's a mindset strategy for creating secure software, with the idea that we get the security by piggybacking on our internal drive as developers to use good designs.
And the misconceptions of how to design domain primitives actually could yield, you know, anemic domain objects. And this anemia opens up for new vulnerabilities of, you know, code misbehaving outside of the objects.
And that was not the intention. The intention was that the domain primitives should be rich objects that are not anemic. So on the validation part, we realized that the focus on in-data validation, input validation, has put state validation into shadow, so that it hasn't got the attention it needed. And that might also lead to other problems, like being able to add a book to a paid order, which is not yet shipped, and you get that extra book for free.
And finally, of course, the, you know, path towards full-fledged secret rotation is sort of paved by subtle dead ends. I mean, one of them being, of course, the config injection at startup. If you're not careful, you might end up in a very big technical debt, I would say. So
this is a little bit of our insights, looking back to basically the last 5 years of seeing software secure by design in practice, and some of the misconceptions that we've seen and where they end up and where we would like to clarify.
Yeah.
And that kind of like concludes the presentation here. So
thank you.
Thanks a lot for honor and attention.
Yeah, you might have some time for some questions, I think, like 5 minutes or so, 4 or 5 minutes.
Yeah, thank you very much, Dan and Daniel. I appreciate that talk very much. Looks like we've got about 4 minutes left. So if anyone has particular questions that they'd like to ask, either in the Zoom, I'm sorry, in the Slack Room C channel or in the Zoom chat. That would be great. I guess, I mean, while we're waiting for maybe a question to come in, I mean, my question that I have, and you've answered parts of it during the presentation, but is there a typical engagement that you have with a client, or are there things that you almost always see with clients that you would like to share?
I mean, I think one thing that I tend to see in a lot of places is that, I mean, you have legacy code. And in our book, we cover legacy code quite extensively, and how to start addressing those particular constructs that you have in place, and how you should start securing up your software. I mean, you can't do it all at the same time. You have to start somewhere. So we have some good patterns around that that we tend to, start applying and start, covering some parts of the system first, and then, moving in a good direction.
Okay, I see there's a couple of questions in the Zoom chat. The first one is about, are there any frameworks or libraries that you currently observe your rules and practices?
To our delight, we've seen that actually, for example, there's a lot of good security drive in all packages. We are using for example, the validation framework having given good support for this contract testing. We also start seeing that frameworks are starting using a move towards domain primitive style. For example, the Microsoft C# framework has got file, which is a record, but then we've got file info, which is more of a handle, so that it can more represent the path and not the underlying file. And so we see gradual changes in this direction, but there's still a lot to happen.
Okay, and I think we have time for one more question. It says here, how do you see quality assurance playing a role in Secure by Design?
Oh, yeah.
Tight loop cooperation, I would say. Quality assurance, preferably as being a function inside the team rather than as a separate team, which means that the insights of a skilled quality assurance professional we've got a follow-up question if it's dedicated or unit test information, and I would say both. Of course, developers will provide unit tests to their code as part of the development process, like for scaffolding it. But a QA in close cooperation with the team will give a lot of inspiration to enhance those unit tests or contract tests or solution tests or automated tests as well.
I've been in projects where the QA specialists inside of the team, of course, they create or set up, I guess, environments that are evil, so to say. Let's say you have dependency to the database, and suddenly the database returns, data in a random rate. It could be very slow, could be very fast, could be very large payloads and such. Everything tried to sort of stress those type of, how should I say, the type of errors that you can introduce by not designing your code properly and making, vulnerabilities that way. So a very good QA person have all this knowledge in designing, how should I say, an evil environment that your application needs to work in.
So we want to clarify that Secure by Design by no means replace dedicated professionals of security insight or quality insight. Rather, in a more like agile organization way, we want to close those loops into very tight corporations so that it builds upon.
All right, I believe we're out of time. Thanks very much for those answers, and I would encourage everyone to continue the discussion in the Room C Slack channel if there are other questions moving forward. And once again, thank you very much, Dan and Daniel.
Thank you.
It was an honor. Thanks a lot.